All right, AS, so now we're going to go into part 2, which is going to be conversions. So we are on part 2 of our math stoichiometry, and we're going to convert grams to moles, okay? And we have to figure out, well, how is everything related, okay? Well, things are related because one molecule of something, right, is the weight of that molecule. So what I mean is, like, for example, water, H2O. If you take the molar mass of H2O, you can get 18 units, 18 atomic mass units, which we said was the same as 18 grams in 1 mole, right? So we're going to learn to convert between all our units. Okay, so let's figure something out. How many moles of sodium chloride are present in 305 gram sample of sodium chloride? Okay. Now, the best way to figure out how to do conversions is basically just to do them and to gain some practice. Practice actually helps make everything very fluid. So we have how many moles? Here's the question. How many moles of sodium chloride are present in a 305 gram sample? Now, it doesn't say of sodium chloride, it implies it, but I'm going to go ahead and write this so that we're not confused and we know exactly of what we're talking about. So we're looking for moles of sodium chloride, and we are given a 305 gram sample of sodium chloride. Okay. So given the following, we're given the molecule's name. We know that we have sodium chloride. And every time they're given some sort of molecule, you always want to take the formula mass of that molecule itself. So we're going to look at a periodic table. So let's look at a periodic table, the peak table. And in the peak table, let's see. We have sodium, which is at a 22.9, and I'm just going to go ahead and say it's 23. Going to round it up. Plus chlorine, which is 35.45, and I'm just going to say it's 35.5. This gives us a mass of 58.5 grams. So that's the formula mass, right? And we were able to detain that because it gave us this molecule. The other thing it tells us is that there is 305 grams of the sample of sodium chloride. All right, so that's what we're starting on. We want moles of sodium chloride. Okay, that's what we're looking for. So this is a very simple conversion, and we're just going to do one step. We're going to go from grams to moles. Now, let's look at our conversions that we can use, or equalities that we can turn into a conversion. Okay, so the equality that we have that we're going to use for the conversion is going to be our weight right here. So we have 58.5 grams is equal to 1 mole of sodium chloride. Okay, this is the equality. So the conversion is going to look like this. 58.5 grams over 1 mole. Or, because it's an equality, we could say 1 mole over 58.5 grams. So we could use either one of those depending on what we need. So the best way to know what you need is to always start with your given. We were given 305 grams. So we're going to start off with 305 grams of sodium chloride because that's what we were given. Always start off with your given. Now we want to get rid of grams and we want moles on the top. And the only number we can use is going to be from this equality, which is in grams per mole. So remember, we want to get rid of grams, so we want to cancel out grams, and we want to obtain moles. Now, one of the things I like to do is the unit that I have here on the top, swing, bring it down to the bottom. You got to make that noise too. It really works if you just go swing and make the noise. All right. So we brought the grams down, and what we want, the unit we want, is going to go on the top. So now easy peasy, we know we're going to be using this conversion factor right there. So 1 mole over 58.5 grams. I'm going to take my handy dandy trusty calculator that I put somewhere, hidden somewhere interesting, and let's see what we get. So I'm going to take 305 and I'm going to divide it by 58.5. Now, some of you guys are wondering, why am I showing you that division? Well, some of us have a hard time multiplying still. And if you are struggling with the multiplication and division, I mean, just go to a math tutor. They really, really do help out, especially understanding the different ways in doing the mathematic, like symbolism, because it's something that we do know how to do, but sometimes the way something is written can confuse us. And if that's the case, you could always email me, right? Or just go to a math tutor and have them help you out with the different variations of doing the problems. Okay, so we took this and we divided it by that, and we ended up with 5.21. I'm going to write a whole bunch of numbers down. 3, 6, 7. Okay. And now let's go ahead and cancel out the moles, the units that don't belong. Grams divides with grams, right? Grams over grams is equal to 1. So grams over grams is equal to 1. So they cancel out. Moles does not cancel out with anything. Therefore, my unit is going to be mole. Now we're going to go ahead and apply our significant figure rules and make sure that we have the correct number of significant figures. Based on the given, we are given 1, 2, 3 significant figures. So my answer is going to have 3 significant figures. It's going to go to this spot right here. Next to the 1 is a 3, so it does not round up. So therefore, my final answer is going to be 5.21 moles of sodium chloride. All right. So when you write your answer, you want to make sure, one, it's in correct number of significant figures, you have the correct unit, and you're telling me of what, right? So let's write those things down. Your answers must have, 1, correct sig figs. 2, the correct unit. You have to tell me of what. If you don't tell me of what, I'm just going to say 5 point what? 5.1 dollars, 5.1 cups of coffee. Like, what is it? And of what? So what molecule, what atom? Okay, so this is number 1, the correct significant figures. This is number 2, the correct unit. And this is number 3, of what? What do we have? So there's our answer for the conversions of grams to moles. All right. And they must have they rounded differently than I did. So I rounded on this one based on my periodic table. Their periodic table is a little bit different. We still got 5.2, 5.2. All right. Let's go ahead, and now we're going to do some more calculations involving conversions. Okay, so let's look at this one. To prepare a solution that contains 1.2 moles of sodium chloride, how many grams of sodium chloride are needed? So we're using the molar mass in order to convert. Now we're going to be a little bit different. Now we're given moles. So we're going to go from moles to grams. Okay. So this was grams to moles. Now we're going to go from moles to grams. All right. So in my question, it says we have a solution. How many grams? Okay, so how many grams of NaCl are needed to prepare a 1.20 mole NaCl solution? solution. There we go. All right, so what are we given? What is our given? Our given here is 1.2 moles of sodium chloride. So we're given 1.20 mole of NaCl. We're also given sodium chloride, which we figured out has a molar mass of 50. Let me look. We said 58.5. Okay, of 58.5 grams per mole. We want, okay, grams of sodium chloride. Okay. Our conversion factor in this case is going to be our molar mass, because our molar mass has grams and moles in it. So we have 58 grams, or 58.5, should I say, 58.5 grams in 1 mole, or we have 1 mole over 58.5 grams. So we have to figure out which one we're going to use. So starting with the 1.2, always start with your given moles of sodium chloride. We want to go ahead and cancel out the mole and obtain grams. Now remember that little trick I showed you guys? You take the unit that you start off with and you go shwing, bring it down. So the mole ends up at the bottom. So now we have mole at the bottom, and on the top we are going to write what we want, and we want grams of sodium chloride. And this is mole of sodium chloride. Okay. We could see that we're going to be using this conversion factor right there. So 58.5 over 1 mole. So we're going to take our handy dandy calculator and we're just going to multiply these two across. So 1.2, okay, 1.2 times 58.5. And I got 70.2. And the unit, well, let's figure out what our unit's going to be. Mole cancels out with mole, and we're left with grams. So my unit is going to be grams of sodium chloride. Now, let's double check, make sure everything is correct here. Do we have the correct number of significant figures? 1, 2, 3. 1, 2, 3. That's correct. Do we have the correct unit? Yes. The unit's in grams, and it's asking for grams. Of what? Sodium chloride? This is perfect. So we box up our final answer, and that is done. So all we did was the opposite, and you notice that we always start with the given. So this is my given. So you start with the given. In this part right here, we just brought the unit down. In this section here, we use the conversion factor. And we cancel out the units to make sure that our units are correct. So those are kind of like the simple little steps of how to solve these problems. Okay, same little steps, boom. All right, now the next part is going to be converting between moles and particles. So we're going to be converting between moles and particles. Moles and particles. And remember, particles is the same. We could use atoms, molecules, or whatnot. But the big thing is knowing that when we're using the word particles, our new conversion factor is going to be Avogadro's number, in which it's going to be 6.02 times 10 to the 23rd number of particles, atoms, molecules in 1 mole. So we could use it like this, or the opposite, in which we say 1 mole over 6.02 times 10 to the 23rd particles, atoms, molecules, any one of those, right? So this is going to be the new conversion factor that we're going to be using to convert between moles and particles. All right, the example, how many atoms are in 4.2 moles of gold? So atoms in 4.2 moles of gold. So I'm going to write down my given, which is 4.20, actually, moles of gold. And we want to convert this into atoms. So to go from moles to atoms, we're going to use Avogadro's number, which is this number here, the 6.02 times 10 to the 23rd, right? So, like always, start with your given, 4.20 moles of gold. Have to figure out which conversion factor we're actually going to use here. So we're going to shrink the moles down. So moles are going to end up at the bottom, which means Avogadro's number is going to be ending up on the top. So this is particles, 6.02 times 10 to the 23rd over our 1 mole. All right, guys, so now that we have our problem set up, okay, it looks just like it does right here, we're going to go ahead and calculate and see if we could get the correct answer, which we are. We're going to take the 4.20, so 4.20, and realize you can't really see that, but we're now going to go ahead and multiply it by Avogadro's number. So when we use this, we're going to multiply it, and this is how we're going to write Avogadro's number now. 6.02 times 10 to the x and the 23. Enter. So you notice that I didn't push times 10, like I didn't push times and I didn't push the 10 there. That would actually created something completely different. Now, not all calculators have this times 10 button. Some calculators have a different option on them. So let's go ahead and write down our answer. Let's verify. See here, we did it correctly. 2.53 to the 24th to the 24th power. So my final answer was 2.5284 times 10 to the 24th power. Right? Now let's look at significant figures. We have 3 significant figures as our given, so my answer has to go in 3. That's where this 8 is going to round that 2 up. So therefore my final answer should be 2.52 times 10 to the 24th. And in this case, our answer, the question said atoms. So we're going to put this in atoms. Of what? Of gold. Okay. So we'll notice here it says particles. And you're like, well, you put atoms. So when we're doing Avogadro's number, remember it's the number of particles. So particles is equal to 1 mole, right, is equal to Avogadro's number of particles or atoms, molecules, units, etc. Okay, so it's of whatever it's asking you of, right? If it's something different, if it's not grams, if it's not moles, right? If it's not liters, you're using this right here. All right, so let's talk about the options in your calculator that you might have something. Your calculator, so mine has this times 10 to the x option on it. Okay. Your calculator might have the EE option that looks like this. It might have the EXP option that looks like that. So what this basically is telling us, so if I had the 2 times 10 to the 3rd option, I want to put it in my calculator here, I would put the number 2, then I would push this, and then I would put a number 3. If I had this one, I'd do exactly the same. 2, this, and 3. 2, this button, and then the 3. I'm not going to push the multiplication symbol on here because that's going to give me something completely different. These buttons here all represent this, which means to the power of 10. And then how many times are you going to multiply it by the power of 10? So this is 2 times 10 times 10 times 10. This is 3 times. So you're multiplying by 10 3 times. Okay. So look for your calculator and check for these buttons. Some of them might require to use the second shift option. So it'll have like second, or it'll say shift on it, and you might have to push those before you push one of these two. All right. Now we're going to go into atoms to grams. So now we're going to do 3-step conversion. So this is going to be a 3-step conversion. Atoms to grams. And in order to do atoms to grams, we have to relate everything together. So we're going to go from, well, these are all going to be vice versa in conversions, moles and atoms. So we've dealt with grams, moles, and atoms. Now we can go this way, convert grams to moles, and we can convert moles to atoms, as we can convert atoms to moles and moles to grams using the reverse method. So using the other conversion factor. So the question here is, what is the mass in grams of 2.53 to the 23rd iron atoms? Okay. So we're going to go from atoms all the way to grams. So that means we need to go from atoms to moles and from moles to grams. Okay, based on the question that we're being asked. Now, as I've said, we always start off with our given. Our given in this case is 2.53 times 10 to the 23rd iron, so Fe atoms. Okay. That's how many atoms of iron we have. Now I want to convert this into moles. Okay. And then I'm going to convert it into grams. All right, well, first things first, to see the unit that we have here, bring it on down. We're going to write atoms at the bottom. Okay. Now, which conversion factor have we used that has atoms in it and has moles? That's Avogadro's number. So in 1 mole, there is 6.02 times 10 to the 23rd atoms. All right, we're done with that part. Now we're going to bring the mole unit down, and the unit we want, which is grams, on the top. Okay. So if we look at our grams to mole, right, this one right here was using Avogadro's number. This one, grams to moles or moles to gram, is using the molar mass or the formula weight. Molar mass. So that means we have to find out the molar mass of iron. Okay, so we're going to get our fancy little periodic table. Let's see if we, oh, I closed the P table. Open the P table back up. Okay, now we're going to find iron. Iron is right here. It is 55.845 grams. Okay, in 1 mole. All right, so that's going to be our molar mass value. Okay. Now, if we cancel out the units that don't belong anymore. Atoms cancels out with atoms. Moles cancels out with moles. They don't belong anymore. And we're left with grams, and that's what we want, right? How many grams are in this? Okay, so all of that is good and clear. Now, some of us might want to rewrite this because we look at it and go, oh my God, what am I doing? These units are so confusing. Okay. Just rewrite it. If that helps you, by all means, right? So 2.53 times 10 to the 23 times 1. So you're just going to multiply that by 1. You don't really have to write the times 1, but just to write all our steps down. Times 55.845 divided by, so at the bottom of all this, we're going to divide it by, well, this is just the 1 right here, so I'm not even going to put it. 6.02 times 10 to the 23rd, and divided by, well, another 1, since I already put the 1 down. All right, so let's go ahead and do this. So grab our fancy dancy calculator, 2.53 to the 23rd. Let me see if I turn on one of these lights. Okay. Okay, hopefully see things a little bit better on the calculator. All right, so the 2.53 times 10 to the 23rd, and we're going to multiply it by times 55.845 is equal to that. And now we're going to divide it by Avogadro's number by 6.02 to the 23rd. All right, we're left with 23.4697. So it's equal to 2, 3, 4, 6, 9, 7, ... Let's finish this up. Okay, so the way we report our answer, correct number of significant figures. Starting off, we are given 1, 2, 3 significant figures. That's right here. That 6 is going to round up that 4. So my answer is going to be 23.5. The units that we're using are grams. Grams. Of what? Iron. Okay. So what this means that in this many atoms of iron, I have 23.5 grams. Okay, so I could weigh out 23.5 grams, and I know it's going to have this many atoms inside of it, right? Kind of cool. Dun, dun. All right. So how did we do this? Well, quite simple. We just followed the steps. So we used the molar mass to go from grams to moles. So from here to here, we used molar mass. And from here to here, we used Avogadro's number. All right. So now we're going to use an equation, and we're going to use the equation to actually help us solve for some of these problems. Okay. So in this case, we have hydrogen and oxygen to produce water. Let's look at the molecular ratio in which it's getting produced. We need 2 molecules of hydrogen to 1 molecule of oxygen to produce 2 molecules of water, of H2O. Our masses are equal to each other. 4 and 32 is equal to 36. All right. Now let's look at the mole ratio, right? 2 hydrogen molecules plus 1 oxygen molecules gives us the water. Okay, very similar. Instead of using the word molecules now, we're going to use the word moles. 2 moles, mole 1, mole 2. In this case, this is molecule 1 and molecule number 2. This is kind of like saying it's now in a package, okay, packed up together. It's all grouped up. All right. So using a balanced chemical equation, we're now going to start solving the same type of problem. And now we're going to be using our balanced chemical equation. Okay. So use the balanced chemical equation to convert units. Right? So things that we get to understand from our balanced chemical equation are how many moles of iron react, how many moles of hydrochloric are needed, how many moles of iron 2 chloride form, and how many grams of iron 2 chloride form from this. So I took some very nice notes so that we could use together in this one. So if you guys could follow along with these, that'd be splendid. All right, first thing is first, we're going to write down our equation and make sure that it is properly balanced. So we have iron solid plus 2 hydrochlorics aqueous produces iron chloride aqueous plus H2 gas. Okay. Make sure everything is balanced. 1 iron, 2 chlorines, 2 chlorines, 2 hydrogens, 2 hydrogens. Okay. So let's write this in different steps. So question 1 or A says calculate the moles of iron reacting. So actually, let me write this up here. So if 235.0, I'm going to add the 0.0 to this one here, grams of iron react in the equation below. A, calculate the moles of iron reacting. All right, so we want to calculate the moles of iron reacting. So what are we doing here? In this problem, it seems that we're going to be going from grams to moles. So we're going to go from grams to moles. All right, so what that means is that we have to use the molar mass. So we're going to have our 235.0 grams, and we are going to use the molar mass value and the molar mass of iron. So if we remember this unit, shwing, bring it down, grams and mole on top. So in 1 mole of iron, which is Fe, there is, what was it, 58.845 grams of iron. Right? Grams of iron cancel out with grams of iron. Now we're going to use our trusty dandy calculator, 235 divided by 58.845, and we get 3.9935. So I'm just going to go ahead and do it in our significant figures right now. 1, 2, 3, 4, right? So this is going to be 3.994 moles of iron. Okay, that's what we end up there. Now, using the same equation, B wants us to calculate how many moles of hydrochloric. So this one now, how many moles of hydrochloric are needed? Wow, this is a little bit different because you'll notice that we're not given hydrochloric, we're given iron. So what do? Like I said, it's a little bit different. Don't worry, don't trip. The balancing chemical equation has something to help us out with that. So here are our values. 1 mole of iron, 2 moles of hydrochloric, 1 mole of iron chloride, to 1 mole of H2. So the conversion factor that we're going to be using is going to come from up here. In 1 mole of iron, there is 2 moles of hydrochloric acid. Okay, so let's go ahead and start writing this, and then we'll see what I mean. So we have 235.0 grams of iron. That's what we started off with. And we're going to convert this into moles. So we're going to go from grams to moles. And so grams comes to the bottom. And then we're going to have 1 mole on the top. And using the same number we did up here, it's the same exact steps. 845. Right? Grams cancels out with grams. We're left with moles of iron. This is iron, remember that. We don't want iron, we want hydrochloric. So we're going to add another step to this. And in this step, we're going to be using our mole to mole ratio. Okay? Our mole to mole ratio is going to come from up here. Now, the 1 mole of iron, well, not the 1, but the moles of iron comes down here. And then the mole of what we want, which is the hydrochloric, is going to go on the top. Now we're going to get these numbers from up here. Here's my mole of iron, and here's my mole of hydrochloric. There is 2 moles of hydrochloric in every 1 mole of iron. So now, grams cancels out with grams, moles cancels out with moles, and I'm left with 2 moles of hydrochloric. I do my mathematics and figure out, well, what is the actual answer? So 235 divided by 58.845 times 2. And my final answer is 7.987 moles of hydrochloric of HCl. So that's how many moles of hydrochloric are inside of this solution right there. Next question is, how many moles of iron 2 chloride? Okay, so next one is, how many moles of iron, Roman numeral 2, chloride? How do I know it's iron 2 chloride? Because when it's written here, it's actually iron 2 chloride. But we could see it here as well, that there's 2 chlorines. So therefore, the charge of this iron has to be a positive 2. Okay, so how many moles of this form from this above reaction? That's the next thing that we want to know. All right, so now we're going to go from grams of A, or grams of iron, to moles of iron, to moles of moles of iron, to moles of iron chloride. I'm just going to call that B. To grams of iron chloride, which is going to be my other B. So we have, oh, we don't need grams, so we don't need this step right here. So we're just going to do these 3 steps all over again. Okay, so I'm going to have my 235.0 grams of iron. Then we're going to do that mole-mole conversion that we've done up here. 1 mole of iron, bring that unit down, grams of iron, 58.845. Okay, multiplied by the moles of iron 2 chloride, so 1 mole of iron 2 chloride. Actually, I didn't have to write that whole thing down. I could have just wrote FeCl2. Okay, and how many grams of iron 2 chloride? So where do I get the moles per gram number from? Well, I'm going to moles. Moles to moles. So we don't even need that. We just need moles. Sorry, got distracted here. Moles of iron from the balanced chemical equation. So erase that. My bad. All right. grams of iron cancel out, moles of iron are going to cancel out, and we're going to left with moles of chloride. I'm not even sure if this is a 1 actually, because we have to look at the balanced chemical equation. So for some reason I started dozing off there. All right, 1 mole of iron chloride, 1 mole of iron chloride. All right, that was correct. Moles of iron, 1 mole of iron. So I'm just going to put a 1 down there, and that should be fine. You'll notice that the 1 and 1 actually cancel out. Nothing happens there. So we're just going to end up with 235 divided by this 58, which is the same thing that happened right over here. So therefore, my final answer is going to be 3.994 moles of FeCl2. That was the beautiful thing about that 1-to-1 ratio, is that that answer actually didn't change for that. Let's see. What do we got next? The last one is how many grams of iron 2 chloride form. So now we're actually going to that final step. Let me perk up a little bit here. Drink some Turkish coffee. Kind of strong. All right. How many grams of FeCl2 form? Right? We want to know how many grams of FeCl2 form. Now we could write the whole thing over again. We could take shortcuts because we already have moles of FeCl2. But because we are learning this for the first time, we're not going to do a shortcut. We're going to rewrite these steps all over again to make sure that we get this correctly. So we're going to go from grams of A, moles of A, moles of B, to grams of B. 4 beautiful steps. All right, now I will show you guys this. When you are doing this and you're trying to figure out, oh my God, what units go down, what go to the bottom, if you figure out the steps that you need, boom, do this and bring these units down diagonally. Grams of A. Bring it down. Moles of A. Bring that down. Moles of B. So now you've actually set up, it's like your skeleton structure of what you need on the units alone. And by looking at this, you're able to figure out, well, where's everything coming from? This right here is going to be your given. Okay. Moles per grams is going to be your molar mass. And that comes from your periodic table. Moles to moles is going to be your conversion factor from the balanced chemical equation. So this is called your mole ratio. Ratio. And it's from the balanced chemical equation. Balanced chemical equation. And grams to mole is, again, your molar mass. And it comes from the periodic table. Now, this is molar mass of your first molecule of your given, and this is molar mass of the second molar of what you want. So this is of your given, and this is of what you want. Okay, and your mole ratio, what you want goes on top. So it's going to be over what you want, over what you want over your given. Okay, so those are some little things to remember from when we set up our problem, and now you just plug in your numbers and solve away. All right, so let's go ahead and plug in some numbers and solve away. So our first one, our given is 235.0 grams. The next thing we have is moles per gram. So in 1 mole of iron, there is 58.845 grams. Our mole ratio, moles of iron chloride, there is 1 mole of iron chloride in 1 mole of iron. Our next step is the molar mass of iron 2 chloride. So we have to figure that out, FeCl2. We're going to grab our periodic table and Iron is 58.45 plus chlorine, which is 35.45, and there's 2 of those, so I'm just going to multiply that by 2 to find my molar mass. So we have 35.45 times 2 plus 58.845. Oh, I accidentally multiplied it instead of added it. Plus. All right, redo. 58.845 plus 5.45 times 2. Here we go. Is 129.745. So we're going to put the grams that we just found, which is the 129.745 grams of iron 2 chloride over the 1 mole. Okay. Let's allow our units to cancel out. Okay. Grams cancels out with grams. Mole cancels out with mole. Moles of iron chloride cancels out with moles of iron chloride, and I'm left with grams of iron chloride, which is exactly what I want. So now I'm going to go ahead and calculate this mathematically. I'm going to take my 235.0 divided by my 58.845. I don't have to worry about the ones, and I'm just going to multiply that by 129.745. Okay, and I end up with 518.14. That's the number of grams. So my answer is going to be in 4 significant figures. So I don't really have enough space up here. I am going to see if I can write it as 518. 518.1 grams of iron chloride. All right. And that's doing a multi-step conversion of all our numbers. All right. Whew. So remember, stoichiometry is basically predicting using mathematics, using our balanced chemical equation. It is the science, the math inside of our science. All right. Before we go into these other problems, because most of those are just going to be a little bit of practice to help us out. I want to go through writing a stoichiometry roadmap with you guys. Okay, so I'm going to see if I can do it. Yeah, let's do it this way. So let's do a stoichiometry roadmap. And these roadmaps help us a lot during tests and whatnot. So a stoichiometry roadmap. You notice that everything that we've done evolves around the mole. Okay, so everything revolves around the mole. Okay, from a mole, we're actually able to get grams. So from moles, we can get grams. So we can convert moles into grams. We can convert moles into atoms or particles, formula units, particles, units, molecules, whatever you want to call it. Okay. From here, this is of the first product that we have, the thing that we're starting off with. You could also convert mole into mole. Mole is something else. And to get the mole of something else, you could also use, you could also convert to grams, but this is gram of your second item. Or you can convert again to atoms or molecules, particles, units, formula units, those kind of things of the second one. The other one that's we haven't touched on yet, but is also covered, is going to be our volume. We could also convert and obtain a volume from these. So the volume, you get volume of A, and you can get volume of B. Right. So this is kind of like a stoichiometry roadmap, and now we're going to write what you actually need to do to convert from one thing to another. Okay. So to convert from moles and grams, you're going to need the molar mass. So to convert from here, you need the molar mass. To convert from atoms and particles, you need Avogadro's number. Okay. To convert from volume to moles, you're actually going to need your STP value. STP of 22.4 liters. Okay, and we're going to cover that soon. And the same process is going to go here. You're going to need these values also, but this is molar mass of A, right? And this is going to be molar mass of B because you're talking about B. The rest of these, the numbers stay exactly the same. The only thing that changes is going to be your conversion factor, whether you're going to multiply or divide by a certain number. And that all depends on what you want and what you have. Okay, so let's do an example. If we're going to go from grams to moles, or let's do grams to moles. I'm going to do it down here. Grams to moles. To do this one, you know you're starting off with grams because you have grams. So what you're going to do is, using your molar mass, grams is going to go on the bottom and your 1 mole is going to go on the top, right? Because you're starting off with grams. If you're going the other way around, so if you're going to go this way, then that's going to change things. You're now starting with mole. So you're going to have mole, and you're going to multiply it by grams over your 1 mole. Okay, that's for your molar mass. So it all depends what you're starting with. You notice that the unit you start with is always the unit that ends up at the bottom. Okay? Using STP values for volume. So STP stands for standard temperature and pressure. And we're going to cover it more in our gas unit. So it stands for standard temperature and pressure, and which is saying that 1 mole of anything at STP, 1 mole of any gas, of any gas at STP is equal to 22.4 liters. So if I'm going to go from mole to volume, let's do volumes to moles. Okay, if I'm going to go from volumes to mole, I'm going to go from liters, and then I'm going to put liters at the bottom and mole on the top. And the number 22.4 is going to be attached to that liter. And vice versa, if I'm going this way, I'm going to start with mole, and I am going to get my 22.4 liters on the top and my 1 mole at the bottom. That allows moles to cancel out, and you end up with liters. Liters is the unit of our volume. All right, let's look at Avogadro's number. Okay. So if we're going to go from atoms to moles, you start off with atoms, and you want to get rid of atoms. So atoms is going to go on the bottom, so that means you're going to put Avogadro's number on the bottom. And it could be atoms, molecules, particles in 1 mole. And vice versa, here at the bottom, you're just going to reverse the process, going from moles into atoms. So this right here is going to be called our stoichiometric flow chart, right? The stoichiometric flow chart. And just because we've done it for all of them, let's just finish it up. And in this case, we're going to go, we have moles. Okay, we want to get rid of moles, so Avogadro's number is going to go on the top and a 1 mole at the bottom, and this is atoms. Okay. All right. Beautiful stoichiometric flowchart. You can actually Google some, and you'll get those ones there. We have some more problems to go through, and a couple of theoretical, percent yields, limiting reagents kind of problems. So we're going to cover those in a different video. So this is it for part 2. Stay tuned for part 3.